Hello everyone, welcome to video lecture series on programming with C. In this session, we'll discuss about pointers in C. Simply put, a pointer is a variable which is used to store memory addresses. What are memory addresses? Whenever we run any program, it is loaded in RAM. All the components of program are also loaded in RAM. For example, let's say we have a variable x with value 5. It is also loaded in RAM at some memory location. If I want to access the address of memory location where x is stored, I can use pointers. Let's see how to use pointers in C. Basically, there are two parts. The first part is pointer declaration. To declare a pointer, we have to specify data type followed by asterisk operator followed by the variable name of the pointer. The asterisk symbol can be specified after data type as well as before variable name. This line creates a pointer variable of type integer. The second part is to initialize pointer. As discussed earlier, a pointer variable can store only addresses. So what we'll do, we'll declare another variable, say int a is equal to 20, and we'll assign the address of a to pointer ptr using ampersand operator. So here we have used two operators. The asterisk operator is used to declare a pointer, whereas the ampersand operator is address of operator. We can print the value of pointer variable ptr. To print the value of a pointer, we have to use %x as the format specifier, because a pointer variable stores addresses which are in hexadecimal format. If we compile and run this particular code, what we will get is the address of the location where a is stored, and this value is stored in the variable ptr. How to access the value which is stored at ptr? To access the value which is stored at ptr, we have to dereference ptr. And to dereference ptr, we have to use again asterisk operator. So if we compile and run this code, the second line prints value of 20. So you can get the value at the memory location using dereference operator or asterisk. Now let's see how this program is executed. The first line, int star ptr, creates a variable with name ptr and stores it at the memory location 2000. Now this variable contains nothing as of now. We just have declared the variable. Now we have declared a is equal to 20. Similarly, it will create a variable with name a, will store it at location 4000 and will contain a value 20. If you look at the next statement, which is ptr is equal to ampersand a. What this statement does, it assigns the address of a to ptr. It means that now ptr points to a and contains the address of a, which is 0x4000. Now let's see how to change the value of ptr. ptr contains address of a, and now we want to change the value which is stored at a, which is 20. To do this, again we have to use dereference operator like star ptr is equal to 30. What this line will do? It will access the location which is stored at ptr, which is 4000, and will change the value at that location by erasing the old value and assigning the new value. This is how we can work with pointers. Let us see what are features and uses of pointers. Pointers save memory space. Let's say I want to pass a variable as a parameter to function. Generally, we have to make a copy of the variable. Instead of sending a copy, we can pass a reference or the address of the variable. This will help us to save memory space. Pointers make execution faster. Definitely, as we are directly accessing memory locations, the execution would be much faster as compared to the regular variables. Pointers allow us to allocate memory dynamically. As we know, we have two types of memory, stack and heap. Pointers allow us to allocate memory dynamically on heap. In addition to this, pointers allow us efficient access of data using arrays and various data structures. So pointers allow us to execute program faster and efficiently manage our memory resources. Now let's experiment more with pointers. Say I am declaring a floating point variable, say f1 is equal to 3.5. I am creating a pointer variable int star p, and to this variable I am assigning the address of f1. If you notice here, I am declaring a pointer and initializing it at the same time. Now if we compile this code, let's see what happens. This results into an error saying that cannot convert float star into int. What it means is, to an integer pointer, you cannot assign a floating point variable's address. That is, if I want to resolve this error, I have to declare this pointer as float and this error will go. It means that an integer pointer can store address of integer variable. A floating point pointer can store the address of a floating point variable, that is, the data type of pointer variable and the variable whose address it is pointing to must be same. Now let's try to assign a value to this pointer variable. If I specify a value, say, this will change the value of p to 4.0. That is, the value of f1 will be 4.0. Now, let's say I have another variable float, say x is equal to 2.5, and now I'm trying to assign p is equal to x. If we compile this particular code, it will return an error saying that you cannot convert float star into float. What does it mean? It means that you can only store addresses in pointer variables. Values cannot be stored in pointer variable. Let's discuss about how to manipulate pointers. What are different operators that can be used with pointers? Here in this program, I have declared a variable pointer and I am assigning the address of A to pointer variable ptr. Let's use the pre-increment operator on ptr, plus plus ptr, and print the address or the value of ptr. If I compile and run this code, the output that I'll get is FE14 and 18. What is use of pre-increment operator? The pre-increment operator increments the value by 1. In this example also, it is incrementing the value of PTR by 1, but the value is incremented by 4 because it increments the value of PTR by 1 unit. And here the unit is size of integer data type. The size of int in this compiler is 4 bytes. That's why the value is incremented by 4. Now let's decrement the value of PTR by 1. If I specify this and again print the value of PTR, what we'll get again is the value 62FE14, that is the value is decremented by 1 unit, and here 1 unit is the size of int data type, which is 4 bytes. So we can use pre-increment and post-increment as well as decrement operators with pointers the way we use it with primitive data types. Let's see another example. Here I am printing the value of PTR, that is the address stored in PTR. At the same time, I am dereferencing PTR and printing its value. Let's see what is the output. As you can see, the first line is giving the address, the second line is giving the value. Now let's apply. Now let's try this, wherein I am specifying star PTR in brackets and then I am specifying plus plus operator. Now what happens is it will increment the value stored at PTR rather than incrementing the address. If we compile and run, we'll see the value is 21. So if you want to increment the value, we have to specify pointer in parenthesis. Now let's say we have two pointer variables, PTR and PTR1 as shown here. Can we add these two pointers? Let's say I'm declaring another variable, PTR2 is equal to PTR1 plus PTR. If we try to compile this particular code, it will give an error saying that you cannot add two addresses. So we cannot use plus, minus, multiplication or division operator with pointer addresses. Now let's say we have two pointers, PTR and PTR1. PTR1 is also pointing to the same memory location, which is ampersand A. Now what does it mean? Now let's say I'm changing the value of star PTR equal to say 30. What would be the value stored at PTR1? Let's see. If we compile and run the code, what we will get is 30. It means that now both PTR and PTR1 are pointing to the same memory location, which is the address of A. So we can assign one pointer to another pointer as well. Let's see one more example wherein say int star PTR2 is equal to say PTR1. This will assign the address stored at PTR1 into PTR2. And now we have three variables pointing to the same memory location, which is address of A. We can have something known as double pointer. So how to declare a double pointer? A double pointer can be declared int star star say PTR1 equal to, now a double pointer stores the address of another pointer. Now if I print, say, what it prints is 62FE10. Now what is this 62FE10? To understand this, we'll print ampersand PTR and see what we are getting 62FE10, which is same. Now let's dereference PTR1. If we dereference PTR1 and show its value. We'll get another address which is 62FEC. Let's see what is this address. So if I compile and run this code, what I'm getting is 62FEC for the last line as well. What does it mean? Let's have a look at the code. PTR1 is a double pointer which stores the address of PTR, which in turn is a pointer which stores the address of A. Let's have a look at the code again. The first line here is printing PTR1. PTR1 contains address of PTR. The second line is printing again the address of PTR. The third line is dereferencing PTR1. Now actually dereferencing PTR1 will show the value at PTR. And what is value at PTR? The value at PTR is address of A. And this is how we can work with pointers, double pointers, and pointer manipulation. Thank you everyone.